Welcome to Ask and Learn.
Alrighty, so here we're given the roots from our characteristic equation, and in this case, the roots that we are given are 1, 1, 1, 1, negative 2, negative 2, negative 2, 3, 3, and 4. Okay, so as we make the general form, we say that an will be equal to, and we can start with this first chunk. So it's 1 with multiplicity 4. So it's going to be, alpha 1 times 1 to the power of n plus alpha 2 times, this time because of the multiplicity we'll have an n, times 1 to the n, plus alpha 3 times n squared, again because of the multiplicity, times 1 to the n, plus alpha 4 times n cubed times 1 to the n. Okay, and so that then covers all the ones, and then we'll switch to the twos. And so if we go to the next line, we'll just say plus alpha 5 times negative 2 to the n plus alpha 6 times, and we're still in this multiplicity concept, right? So we have to multiply this one by n, times negative 2 to the n, and plus alpha 7 times n squared times negative 2 to the n. And so now we'll do the threes. So we'll have alpha 8 times 3 to the n plus alpha 9 times n times 3 to the n. And lastly, this 4, and I copied that down wrong, so I could say negative 4 is our root, so it'll be negative minus, so plus alpha 10 times negative 4 to the power of n. Okay, and so we can simplify this a little bit because 1 to the power of n is always just going to be 1, so you can clean it up by taking that out. And so for that top, it would just be alpha 1 plus alpha 2n plus alpha 3n squared plus alpha 4n cubed. And then that gives you your final solution. Okay, so just in the general form, it's going to be this big long thing.